Okay, so let's make sure we read this carefully. Everything on this top left section is incorrect. These are all common mistakes. Okay, so we're gonna see the correct way of doing these. Okay, so the problem was x to the third times x to the second. And a very natural answer would be, oh, 3 times 2 should be 6. But that's actually not correct. Okay, so here's the correct way to approach it. X to the third means you have 3x's multiplied together. And then you're multiplying that by x to the second power, which means 2x's multiplied together. Okay, so when you combine those together, you see you have 1, 2, 3, 4, 5x's in the end. Yeah, so even though it's a multiplication problem, you actually add the exponents. Um, yes, you're right. When we were finding the degree, you added together the exponents. Okay, so yeah, that'll be something we want to remember. When you multiply two different terms with the same base, in this case x, you add the exponents together to get the new exponent. Okay, so now that we've seen the correct way to do this, we're going to jump down to the bottom half of this page. Okay, so this is called the product rule. Um, right, so here I didn't use specific numbers, I just used letters. But when you multiply, again, two things with the same base, we just saw the pattern is that you add the exponents. So you keep whatever base was there before, but then you add the old exponents, I should say, to get the new exponent. Okay, and let's add in an example in this space. Let's say I ask you to do 4 to the fifth power times 4 to the seventh power. Very good. You do not multiply the 4 and the 4 together. According to this, you just keep one of them. You don't multiply it together, but you then take the old exponents and you add them together to get the new exponent. Yeah, yeah. Okay. So yeah, it's very confusing, right? Because you think for a multiplication problem, you would multiply, but we can see that you actually add the exponents. We're gonna get to that shortly, but yeah, I'm glad you're thinking ahead. Okay, so now let's look at the second row above. So again, a very understandable common mistake is when students see a problem like this, they say, "Oh, okay, I know that fraction means divided by, so 8 divided by 2 should turn into 4." Okay, so Dominic has a theory. Let's see if it's correct. So x to the 8th over x to the second. The x to the 8th means we have 8 x's all multiplied together. X to the second means we have 2 x's multiplied together. Okay, and then we know that when we reduce fractions, we're allowed to cancel out a common factor of the numerator and denominator. Okay, so we can get rid of one pair of x's, one each from the top of them and the bottom, and we can cancel out a second pair of x's. Okay, but we can't do any more because there's no more x's on the bottom. Okay, so what are we left with? 1, 2, 3, 4, 5, 6. Okay, so Dominic was correct. We started with 8 on top, but then we canceled out 2 of them. So 8 minus 2 means you have 6 left over. Okay, so that'll be our pattern for division. Again, you would think that you divide, but you don't. And we see that you actually subtract the exponents. Okay, so this is a little bit out of order. Let's jump down to property 3. Okay, so when you have x to the power of a over x to the power of b, you keep the base x, the thing with the exponents, but then you take the numerator exponent minus the denominator exponent. Okay, and the order does matter. Notice the numerator exponent comes first, and then you subtract the denominator's exponent. Okay, so again, we'll just add in a little example in this empty space. Okay, so let's say you had, it doesn't have to be x, it can be any letter. So let's say you had r to the power of 7 over r to the power of 3. You would keep the base of r, and you would do numerator minus denominator exponent. Okay, and so in words, if the bases are the same and we divide two expressions, then we subtract the exponents. Okay, going back up, third row. Okay, so here we have x to the power of 2 already, and then that whole thing is now to the power of 3. So we have an exponent to another exponent. So again, the common mistake would be, oh, when you have a power to a power, right, 2 to the power of 3, 2 times 2 times 2 is 8. But it turns out that's not correct. Okay, so again, we have x squared in parentheses, all to the power of 3. Okay, so the first one, we can rewrite x squared as x times x. And because that whole thing is to the power of 3, we're going to write that parentheses 3 times. Okay, so looking at it this way, we have 3 groups of 2 x's, right? So, or we can count one by one, 1, 2, 3, 4, 5, 6. Okay, so it turns out that x squared all to the power of 3 becomes x to the power of 6. Okay, so here we do multiply the exponents. Okay, so make sure you see the difference between the first situation and the third one because they're very similar, right? But when you have two different x terms multiplied together, that's when you add them. 3 plus 2 is 5. But you see here, the letter x only shows up once. So it's not two different terms, it's one term with two exponents. So that's where you multiply the exponents instead. Okay, so let me just write them side by side so it's easier to see, right? So here there's two different x's, so you add the exponents. Here there's only one x, so instead of adding them, you multiply. Okay, so yeah, very, very common to mix up these two situations. Again, the key difference here, there's two different x's. Here, there's only one. Okay, so we can write that in property 2. Okay, so if you have, some exponent to the power of another exponent, we saw that you, again, keep the base, but this time you multiply the exponents. Okay, so in words, when we raise a power to another power, then multiply the exponents. Okay, so as before, let's go ahead and add an example in this space. Okay, so let's say that we had something like a to the fourth power, all to the third power. You would keep that a, but then the new exponent, you would multiply the two old exponents to get a new exponent of 12. Okay, so continuing on. Okay, so we just said, oh, you multiply the exponents, right? So 5 times 3 is 15. Isn't that correct? There's a different issue with this one. Okay, so again, let me copy down the original problem. Okay, so the exponent of 3 on the outside means we need to write the inside 3 times. Okay, so the x part was correct, right? You have 5 plus 5 plus 5, right? Here we would add the exponents because there's different x's, if not all 1x. But the part that was wrong was the 3, right? It doesn't stay a 3 because you multiply it by other 3s. Okay, 27x to the 50. Very good. So looking back at the original problem, it seems that this exponent, it not only affects the x, it also affects the 3. Okay, so the 3 gets the exponent, and the x to the 5th also gets that exponent. Okay, so yeah, what we want to see here is that when a parentheses has an exponent, both the letters and the numbers are affected by that exponent. Okay, so yeah, that coefficient of 3 in front, it does get affected by the exponent also. Okay, so again, both parts of the parentheses are affected by the exponent. Okay, so this is property 4. Okay, when you have more than one thing in the parentheses, they all get affected by that outer exponent. Okay, right? This C would affect this part, and it would affect this part. Okay, so this one will probably make more sense once we do an example. Okay, so parentheses 5x to the power of 7, and then all of that in parentheses to the power of 2. Okay, so this outer 2 not only affects the x to the 7th, it also affects the 5. Okay, so the 5 gets the power of 2, and then the x to the 7th also gets to the power of 2, which we know from the previous row means times. Okay, so 5 squared is 25, and then x to the power of 7 to the power of 2 becomes x to the power of 14. Okay, so very much related to this. What if you have a fraction in parentheses? Okay, so it seems like I did it right? This 3, I applied it to the 2 to turn into 8. I applied it to the x to turn into x cubed. But it also affects the denominator. It also would go down and change the y squared. Okay, so yeah, the correct way to do this problem is to make it affect everything. So the 2 becomes 2 cubed, the x becomes x cubed, and the y squared gets cubed, meaning you multiply the old exponent by 3. 2 cubed, 2 times 2 times 2 is 8. X cubed is just x cubed. And y has a new exponent of 2 times 3, which is 6. Okay. So yeah, when your fraction is in parentheses, make sure both the numerator and the denominator are affected. Okay, so that's the second part of property 4. If you have a fraction in parentheses with an exponent, both parts get that exponent. Okay, so let's say we had something like 6x cubed over 7 to the power of 2. Okay, every single part will get affected by the exponent. Okay, the 6, the x cubed, the 7. Okay, so 6 squared is 36. X has a new exponent of 3 times 2, which is 6. And then 7 to the power of 2 would be 49. Okay, so going back up to the part. This one is very common, so please make sure you're paying close attention. When reducing this fraction, it's very common to get this incorrect answer. Right, it's easy to say, oh, 3 and 6, divide 6 by 3 to get 2. X to the 5th and x squared, you get rid of, x squared from both sections, so that leaves an x cubed. The y squareds cancel out. The problem is the x cubed and the leftover 2 from the 6, those are both in the bottom part of the fraction, right? So you need to keep them in the bottom part of the fraction. Okay, so the correct way to do this problem, let me copy the original problem first. Okay, so when you try to reduce these, you would divide both numbers by 3. So in the numerator, 3 divided by 3 is 1. 6 divided by 3 is 2 in the denominator. Okay, and then now for the x terms, you've got x squared over x to the 5th. So again, you can write it out. You get rid of as many pairs as you can. So there's an x cubed left over, but it's got to be below the fraction bar. It's in the denominator. Okay, and then the y squareds do cancel out. Technically, they turn into 1, but anything times 1 stays the same. Okay, so yeah, when your leftover terms are in the bottom part of the fraction, they have to stay in the denominator. They can't turn into a regular number. It's still a fraction. Okay, And so that one doesn't have a property on the bottom. So we'll move on to the next row. Okay, so we also have these things called negative exponents. These are very tricky to remember what they do. Okay, so yeah, like what is x to the power of -3? A common mistake is just taking the negative out front. Okay, so to understand this one, let's do a little, let's start with a different problem. Okay, so what if we had x squared over x to the power 5? This is basically what we did above. Okay, so the way we just showed it, right, is we know the correct answer is found by writing it out, canceling out the pairs, and you're left with 1 over x cubed, right? When the entire numerator disappears, you have to leave a 1 behind. Okay, but let's try to resolve this problem using the pattern number 3, property number 3, right? We said that when you divide two terms, you should be able to just subtract the exponents. Okay, so doing that to this problem, you would subtract 2 minus 5. Okay, now notice the order matters. The numerator exponent has to come first. Okay, so even though 5 minus 2 is easier, you have to do 2 minus 5. Okay, so we solved the same problem twice, and we got two answers. So they have to be equal, right? Even though they look different, it's the same problem, so it has to be the same answer, right? So we see that x to the power of -3 equals 1 over x to the power of +3. Okay, so that means that to make a negative exponent into a positive exponent, you move it to the other part of the fraction. Right now, this is not in a fraction at all, so it moves to the denominator. Okay, so let's write that in property 5. To make a negative exponent positive, we move it to the other part of the fraction. Okay, so like over here, if you have any x to the exponent of -a, where a is any number, to make this a positive a exponent, you need to move the x from where it is, which is not in a fraction, into the denominator of a fraction. Okay, and because there's no numerator, we just put a 1 there. Okay, so x to the power of -a would equal 1 over x to the power of +a. So you could also go backwards, right? If you have 1 over x to the power of a, if you don't want it in a fraction, you could turn it to x to the power of -a. Okay, but what if you have a negative in the denominator? Well, when you move it to the other part of the fraction, that would be up in the numerator then. Okay, so for this one, we're going to do a couple examples because negative exponents are very tough to understand. But one thing we need to make sure we are aware of, you can't leave negative exponents in final answer. Okay, so in order to be simplified, you are not allowed to have any negative exponents. Okay, in the middle of the problem you can, but for your final answer, there cannot be any negative exponents. Fraction. Okay, so we're gonna do a couple examples at the bottom here. Okay, so let's say we had 5ab to the power of -4. Okay, so again, we're not allowed to leave this negative exponent, but here there's no parentheses. When there's no parentheses, the exponent only affects the thing right before it. So the 5 and the a are completely unaffected. They stay how they are. But this part with the negative exponent, that needs to move down to the denominator to become a positive exponent. So let's do another example here. Okay, so we have 8x over x to the power of -3. Okay, so there's a couple different ways we could approach this one. But the way I'll show it, we know that when you divide two terms, you subtract their exponents. Okay, so we're going to keep the 8 where it is, but to get a single x instead of two different x's, we need to subtract their exponents. Okay, so the exponent here is invisible 1. Okay, but we got to be careful here. It's this minus this. So it's 1 minus -3. Okay, a very common mistake is just saying 1 minus 3. The subtraction is from the division sign, and then there's a separate negative for the 3. Okay, so instead of doing 1 minus -3, we can add the opposite. So this becomes x to the 4th. Okay, so let me do that same problem in a different way, because it's very easy to get messed up with the minus and negative. Another option is you could leave the 8x alone, and we could rewrite the x to the -3rd power currently in the denominator as an x to the +3rd power in the numerator. Right? Again, to make a negative exponent positive, you move it to the other part of the fraction. So you could move it up to join the 8x by making it a +3 exponent. Okay, and then now from here, again, x is x to the invisible first power. So the very first rule was when you multiply two terms, you add their exponents. Okay, so you see either way, you end up with the same answer. Okay, so questions on any part of this? Okay, so let's jump to this last page. Okay, so here we're just going to combine some of the rules, right? So instead of seeing the rules one at a time, we're going to try to do more than one. Okay, so let's do the top right problem together. Oh, thank you. Okay, yeah, so yeah, back on this page, let's do this one real fast. The 5 is fine where it is. The 5 doesn't have a negative exponent, so we can leave it in the numerator. The 3 is also fine where it is, right? This -2 only affects the x, not the 3. So the 3 is fine, but we can't have a negative exponent. Since this is currently in the denominator, we would make it a positive exponent by moving it up to the numerator. Okay, so there's actually no negative sign anywhere in the answer. Okay, so now let's go back to the third page. And again, we'll do the top right problem. Okay, so there's a lot of stuff going on, right? There's numbers, there's x, there's only one x actually, but then there's like 3 different y's. Okay, so the good news is you can just treat each part separately. So first, ignore all the x's, ignore all the y's, and just focus on the regular numbers. Okay, so in the numerator, you have 3. In the denominator, you have 4 times 3 is 12. Okay, but, well, okay, we can reduce them right away or we can reduce them later. Doesn't really matter. Let's reduce them later. Okay, so we'll just leave the 3 over 12 for now. Next, we'll look at the x. Okay, so there's only one x term, so you can't combine it with any other x's, but we do need to get rid of its negative exponent. Okay, so to get rid of the negative exponent, it moves to the other half of the fraction. Okay, so it started in the bottom, so it'll move to the top. But remember, when you do that, the whole point is to make the exponent positive. Okay, and now there's 3 different y terms. We can just do 2 at a time. So let's leave the y to the 4th for now. And let's focus on combining these 2 together. Okay, so we learned as the first property that when you multiply 2 terms, you add their exponents. Right, y to the 3rd times y to the 2nd means you add them. Okay, so again, I'll just copy everything else for now. Okay, but then down here, we have now y to the 5th. Okay, so the 3 and the 12, you can both reduce by 3, right? Okay, so in the numerator would technically be a 1 for now, and a 4, right? 3 divided by 3 is 1, then 12 divided by 3 is 4. The x squared is fine. We can just leave the x squared where it is. But the y part is tricky. We have a y to the 4th in the numerator and a y to the 5th in the denominator. So again, the pattern we learned is when you divide 2 terms, you subtract their exponents. So when you combine 2 parts into 1, you write it in the numerator. But the new exponent will be 4 minus 5, right? The numerator comes first. Okay, the 1 gets absorbed by the x squared, so we can just write x squared. Keep the y, but the new exponent, 4 minus 5, is negative 1. Don't forget, we have this 4 in the denominator. Okay, we can't stop here. We're not allowed to have a negative exponent. Okay, so we need to make it positive by moving it down to the other half of the fraction. Since it was in the numerator, it moves down to the denominator. Okay, so the x squared is still where it started. The 4 is still there, but the y to the negative first power up top turns into a y to the positive first power down bottom. Okay, and then anything to the first power stays the same, so we don't need to write the exponent of 1. Okay. So any questions on this example? Okay, so you have the rest of the period to work on this page. Anything you don't finish will be for homework.